Okay, if you refer to page 664, this one talks about theorem 8. Your alternate exterior angles theorem. Again, we've talked about these different theorems and what makes them congruent already, but just as a reference point, you'll want to take down this page number so you can always look back and know where you can find it. So take a look at the page 665, right next to it for our next type of example. I want you to look right below in the practice section. So notice here it says find measure of angle 1 and 2, justify each of your answers. So for instance, if I look at number 5, here's 75, and here's our 2. Now we know these lines are parallel. This is our transversal line labeled as T. So I'm going to highlight that transversal. Now something I know about two angles together on a straight line, they have to add to 180. So we know 75 equal 2 has to add up to 180 degrees. And you can justify this by putting off to the side that it deals with a straight line, or you can mention it's supplementary. Anything like that is going to work. So if you subtract to each side, you get that angle 2 is going to be 105 degrees. Now that solves for angle 2. For angle 1, just see its relationship to angle 2. Now it's on the inside between those parallel lines, and it's because it's on the same side and in the interior, we know angle 1 plus angle 2 also has to equal 180 degrees. Well, we know angle 2 is 105. We just had solved for it. So that means angle 1 must also be 75 degrees. So again, reasoning, same side interior angles. Now, if you thought of a different method, that's perfectly fine. There's multiple ways you could have said it. You could have also mentioned that 75 degrees and 1 are corresponding angles, so that if those are parallel, then those must be congruent to each other. So that's another reason you could have put as well. So take a look at number 6. We're going to walk through this one together as well. So notice from A to B and D to C, those two are going to be parallel to each other. So we have to think about 80 and 70 and then 1 and 2 and how we can find that relationship between them. So again, if it throws you off that here it's showing a specific shape, for the parallel lines, always extend it out like it's an invisible line in order to see the relationship between them. So if these are parallel, this is the interior of those parallel lines. So I notice with 1 and 80, those are going to be the same side interior. So if I add 1 with 80 degrees, it should equal 180. So same side, interior angles. So that means angle 1 must be equal to 100 degrees. So let's take a look at angle 2. Now that we know angle 1 is 100, now we can't see a direct connection from 2 to 1 because these two lines from A to D and B to C, those aren't parallel, just the ones on the opposite sides with the arrows. So look at 2 and 70. They're both on the interior between those parallel lines and they alternate sides. So the reason that these can be equal to each other is because of alternate interior angles. So put angle 2 is equal to 70 degrees. The reason being alternate interior angles. Those are always going to be congruent to each other.